Hey everybody, this is lesson 6-3 from your textbook, and we're going to be talking today about defining and using similar triangles shortcuts. I thought it'd be a good idea for you guys to watch a video of me teaching. Since I'm not here today, I'm at a conference day like I'm sure Mr. Wyman has shared with you already. So again, this is section 6-3 from your textbook, and it starts on page 298. So you guys, today we're going to be talking about the shortcuts that are used to determine if two triangles are similar, and you can see them right there on your screen. So let's just talk about those for a quick second, okay? First of all, there's angle, and don't forget this term right here, this little symbol, okay? That little squiggle is not just a little squiggle, it actually means something in geometry. It means similar. So this is the angle, similarity shortcut. And you guys, that means basically that if two pairs of angles are known as congruent, and those are congruent and corresponding angles, okay? If we know that two pairs of corresponding angles are congruent, then we can assume that the triangles are similar. If we just do a really quick sketch down here, and we have two triangles where we suspect that they might be similar, because similar, remember, means same shape, just a different size. And what we have is corresponding angles marked congruent, and we have two pair of those. Then remember, because the sum total in each triangle here and here is 180 degrees, we know that that third angle has to be the same as well. And so then that means that all three angles are going to be congruent, which of course we know preserves the entire shape of the triangle. So that's our first shortcut, angle, congruence, or excuse me, angle, similarity, okay? Moving on to our next one, that's side, similarity. We need to be aware that any time that there is an S there, each S stands for a pair, okay, of corresponding sides this time, because it's an S. And if we have SSS, that of course means we know three pairs, and we know the three pairs are in the same ratio. Okay, so if the three pairs are in the same ratio, and we need to actually do the math and actually determine that, so I'm going to remind you of that, do the math for those ratios. We'll talk about that a little bit more in the next video. But if those three pairs are in the same ratio, then we can assume that even if we don't know anything about the angles, that the two triangles are going to be similar overall. Okay? Okay, and finally, our last shortcut here is our side angle side similarity ratio. Let me just go ahead and scroll down here to give you a bit more room so that we can see what that picture would look like. So this, of course, is the picture here for angle similarity. Make sure you make note of the correct diagram. And then down here we'll make a note for what side angle side similarity looks like. And of course we know that when we have our triangles that are different in size, that we suspect are similar. You guys remember that when we were doing congruence, we had tick marks that we were looking for that would be marked on, let's say, corresponding sides here and here. But we're not going to have tick marks anymore. What we're going to have is actual measurements for those sides. So if we go ahead and put on measurements of these sides, let's say this one is, 7, and this one is 4. And then over here we have 3.5 and 2 on the second triangle. This is almost an instance of side angle side at this point. You can see that we have two pairs of corresponding sides, here, here, and here, and here. So again, that's the 7 to the 3.5 and the 4 to the 2. Those are the pairs that we're talking about. But in order for this to be side angle side, don't forget the A in the middle. Because the letter A is written in the middle of those S's, the angle actually has to be marked in between the sides as well. So the corresponding sides that we would know that would be congruent in a side angle side similarity picture would look something like this. And again, we need to make sure that when we know side angle side, we again know 2 pairs of corresponding sides that are in the same ratio. And a reminder, of course, we are going to do that math. So in this case, we would do the math by saying, you know what, 7 divided by 3.5, I want to know, is that the same as 4 divided by 2? And don't forget that if we started with the 7, which is from the left-hand triangle, then we need to make sure in the numerator on the other side we start with the 4, which is also from the left-hand triangle. And double check yourself, how do we know that this proportion is true? We are going to just do some cross multiplication, and we can very quickly find out that 7 times 2 does equal 3.5 times 4, because both of those products equals 14. So we know we checked out. Okay, so this is what we're talking about, doing the math when you have 2 pairs of corresponding sides. Just because they're labeled doesn't necessarily mean they're going to be similar. So again, we'll talk about that a little bit more in the next video, but those are your 3 shortcuts that you guys are going to need to know for similarity. Remember, with congruence there were 5, so we only have 3 to remember. And again, those are these 3 right here. Angle-angle similarity, all we know is 2 pairs of angles. Side-side-side similarity, and that's now we know 3 pairs of sides that are in the same ratio because we do the math on those ratios. And then the last pair is side-angle-side similarity. So that's what we have as far as our definitions of our shortcuts. Let's move on and use that to solve some problems. Okay, so as we look at this example, which by the way is example 2 in your book that we're looking at, we're asked to find AE and DE. And so I think it's pretty clear that of course we're definitely going to need to find X. Okay? Now I didn't put it on this slide, but in your book you are able to safely assume that these 2 triangles are similar. We need to figure out why that is. So if we go ahead and add some markings to this diagram, then we've got our vertical angles here at point E that can be marked the same. And then don't forget, because of our parallel markings, that is going to lead us to a pair of angles that are alternate interior. So I'm just going to choose this one, angle A and angle D, that are alternate interior. And then now I hope you can see that this is going to be an angle-angle similarity. And the next thing we want to do is to make sure, if that's true, that we go ahead and fill out triangle what is similar to triangle what. So now remember, we can put these triangles, first 3 letters, in any order we want. So if I go B, A, E, then I just need to make sure that the second piece here is going to be in corresponding order. So I'm going to go with angle B goes with angle C. A goes with D because that's the way that we marked it in the diagram, and of course E goes with itself in the other side there. So now at this point we are at our similarity statement gives us, remember we have called it before, our roadmap, which allows us to figure out how do our proportions, roadmap for the proportions that we need to set up to solve for X. Okay, so that's really easy because when we set up and we want to say, let's say we want to find AE, well, AE has this X in it here if we look in the diagram, and that X is X minus 1 is going to be side AE, and if we look in the first triangle there over on the left, side AE is the second two letters, and so AE is going to correspond with the second two letters on the right-hand side. We've done this before a section ago in Similarity, although that was before midterms, so I can understand why you guys might need a refresher here. So here we are, AE is X minus 1 as we're setting up, as we're setting up this proportion, there we go, X minus 1 all over DE, which is X plus 5, and that is going to be equal to any other ratio that we have in the picture. And so if we started with X minus 1 in the numerator, then we need to pick another side from that left-hand triangle BAE. So we'll go with 2 because that's the only other one we have. And 2 is the label for side AB, as we can see here, AB. And AB, the first two letters, corresponds to CD in the second triangle, and CD has a label of 5. So now we're going to go ahead and we're going to simply cross multiply in this proportion here. And remember, cross multiplying is just a way of making it into an equation without the fraction anymore. So this is going to be 5 times X minus 1 equals 2 times X plus 5. And if I distribute, don't forget to do that, we get 5X minus 5 equals 2X plus 10. And then minus the 2X on the each side gives me 3X, and then add the 5 gives me 15. So guys, our X is equal to 5, but remember our problem asked us to find AE, to find AE and DE. So what we want to do is to substitute that back in. Now that we've found 5, we'll put 5 in for X in each of those spots. And we're going to get 4 for AE, and DE is going to come out to be 10. And so I hope that you can see if I put that 4 and that 10 over here into the proportion, it's going to check out for me because I can take my 4 times my 5, which is 20, and also get that equal to the 10 times the 2, which is 20. So we know that the proportion worked out and that we got this problem right. Okay, here's our next example. This one I'm going to have you do a little bit more on your own. So let's go ahead and I'll just put the markings on there and you guys can go ahead and set up the proportion after that. This one is going to be another picture where angle-angle similarity comes into play, if you can see the vertical angles in the middle. And if we go down here with angle Z is congruent to angle Y because those are also alternate interiors. Don't forget we have our parallel markings here again. If our goal is to find VW and WX, then you can go ahead and please take your time and set up your proportion. And once you've set up your proportion, go ahead and solve for X. And then plug that back in to find VW and WX. Go ahead and pause the video now because I'm going to go ahead and put the answer down at the bottom of the screen for you. So just go ahead and pause the video. The next thing you'll see is me writing the answer for you so you can double check your answer. Alright you guys, the answer to this one, the 3 answers that you would need. Along the way to finding VW and WX, you would get that X comes out to be 6, and that VW comes out to be 12, which also makes WX come out to be 10. So, did you get it right? I hope. Okay, almost done here. We're going to go ahead and set up this proportion the same way. Hopefully you can see the angle similarity again, you guys. And go ahead and set up your proportion, find x, and then find what it's asking for, which is RQ and QT. You can go ahead and use the similarity proportions to find RQ and QT. Pause the video now until you're done, and then I'll put the answer at the bottom. Okay guys, the answer just to this one, your x comes out to be 5. Your RQ, once you plug 5 into that diagram, comes out to be 8. And your QT, you guys, finally comes out to be 20. Hope you did okay. Good luck on the homework. Okay, finally, the last thing that you guys need to do before taking up your sheet to Mr. Wyman is to write down this question. There'll always be a question that you need to either reflect on or answer at the end of all these videos. And so the question for today is, I wonder, will I always know that the triangles are similar to begin with? In all the examples that we did today, we started with the knowledge and all of them were the same shortcut, angle, similarity. Will I always know to begin with that the triangles are similar? And I hope you know me well enough to realize that the answer to that is no way, Jose. No, you won't always know that. You'll always need to go through a step of verifying whether that's true or not. But that's what we're going to see in our next video. So for today, that's what we have. You can go ahead and bring up your note sheet to Mr. Wyman, and he will give you the bookwork assignment that you can begin to work on. Thanks, guys.